Let's talk a little bit about expansion tanks. How big should they be? How big a tank do you need? Now, obviously, going back to our example of expansion, water is incompressible. I've got 56 gallons of water I've got to do something with. And hopefully we put it in the expansion tank. That's what the goal would be. Remember, the expansion tank has two reasons to be there. One is control system pressurization that we just talked about. Put pressure throughout the whole system so we know what it is and we can maintain it. The second one is, where do we put the extra water? Where do we expand the water? Those are two key reasons you have the expansion tank. So with a 56 gallon of water, let's just pick a typical tank. We had 56 gallons of water being expanded. So we just took a quickie look. Would an 80 gallon tank, an 80 gallon acceptance volume, a B300, would that be big enough? It's a good question. Would it be big enough? So let's just kind of ask that question. We need to store 56 gallons of water somewhere, the acceptance volume. Will this B300 tank be big enough? So here we go. I got 2,000 gallons of water at 40. It's going to become 2,056 gallons of water at 180. With an 80 gallon B300 bladder tank to be big enough. What is our fill pressure? Our fill pressure is 12 psig. So makeup pressure is 12. We got this closed system. We got a bladder tank. You just stuck an 80 gallon bladder tank on there. Is it big enough to hold the 56 gallons of water? Well, let's go to Charles and Boyle's law and take a look. Well, we got to have a place to put 56 gallons of water. Now we're going to start off with a tank that's 80 gallons of air if it's pre-charged. The nice thing about a bladder tank, if you pre-charge it to the makeup pressure, we could start the tank off with 100% air. We could start the tank off at 12 pounds gauge pressure if we pre-charge it to 12 pounds, so that when we first turn our system on at 40 degree water to makeup water, we got 80 gallons of air in our 80 gallon tank to work with. Great. Now what happens as we heat it up to 180? Well, and that 56 gallons of water is going to go all into an expansion tank. If you take the 80 minus the 56, that leaves 24 gallons of air. Remember, there's a bladder in here separating the air from the water. There's a membrane or bladder separating air from the water. We pre-charged that bladder to 12 and had 80 gallons, and now we put 56 gallons of water into it and compress the 24 gallons of water. That's quite possible, but the pressure's got to go up, right? So how much would the pressure go up? Well, you know, we all go back to high school chemistry and physics, to old Boyle's law. We have to use absolute pressures. So 12 psig is 27 pounds absolute. And we work through the absolute pressure ratios here, we wind up with the pressure V2, pressure P2, of being 75 pound gauge pressure. We started with 12 pounds with 80 gallons of air. We wound up with 24 gallons of air in our closed system, in our little membrane, but the pressure now is 75 pounds. Is that okay? Well, it would be okay unless you used a boiler, like in this case, with a boiler with a 50-pound AS relief valve. So now what's going to happen? Your boiler's going to pop. As you start heating it up, the relief valve is going to pop. So it will not be big enough because the equipment we're trying to protect limits us to 50-pound AS relief valve. Now, not all boilers that way. Maybe we can put a bigger valve on this thing, but the point is, what is the weakest point in your system? That's the max pressure you can put on the expansion tank. So going back to this 50-pound relief valve will discharge, expansion tank is too small. Bottom line, the B300 is not big enough to take care of this problem because of the 50-pound ASM relief valve limitation. So what do? Well, we work our way through some other tank sizes, and we started with the B300. And as you can see, if we went to the next size tank with 106 gallons of acceptance volume, that we wound up with a final tank pressure of 43 pounds. The B500 would also work. It's a bigger tank. The final tank pressure, when we put 56 gallons of water into it, would be 32 pounds. The B400LA and the B500LA, their acceptance volume is too small and they will not work. So a B400 would be okay, a B500 would be okay, a B300 would be okay if we had an ASM relief valve with a pressure higher than 75 pounds, it would be fine. So we could look at the equipment maybe and work at it. So probably would specify the B400 if you have a boiler with a limitation of 50-pound relief valve. That would be the tank size proper for this case. So what is the symptom of an undersized expansion tank? How would you know your tank's too small? Well, I hope you guys understand some of this. Let's look at sizing tanks and some information available for you. We'll put them all up here real quick and I'll run through them. You need to have a good set of software tools for sizing expansion tanks. She'll walk you through this. And Bell & Gossett has an ESP Plus system that's free, it's online, and does a fantastic job of visualizing what we're doing and walking our way through it. In fact, I've got a screenshot coming up that we'll take a look at. I'll kind of keep in mind the higher in the building you put the tank, the lower the pressure will be on the tank. So remember you got Boyle's law you're working with, so the smaller the tank. Remember, the higher the relief valve setting you can put on there, the smaller the tank. Remember, we're working with Boyle's pressure ratios. So the higher the max pressure we can have is that relief valve pressure. So the higher the relief valve pressure you have, the smaller the tank. We would recommend decreasing the max pressure from the expansion tank about 5% below the relief valve pressure. In other words, if I had a 100-pound relief valve in my system, I wouldn't want to take the system pressure any higher and say about 95 pounds. These valves are going to start weeping a little bit before you get there, and you want to give them a little bit of safety room, 4 or 5 pounds, so about 5% when you go sizing expansion tanks. Bladder tanks, if they're pre-charged properly, will physically be smaller than regular compression tanks. They're going to cost more money because they got a bladder. Standard plain steel tank, water in contact with the air, has no bladder, costs less money, but it's going to physically be bigger, and it's going to have to be mounted above the air separator, where a bladder tank can be mounted on the floor horizontal to it. Another little tricky piece, we've always recommended that on chill water systems, use 100 gallons as a field pressure. As your temperature. Use 100 gallons as your max temperature. And you say, well, that's chill water. Yeah, but using 100 gallons, you'll get a tank on most systems, 15, 20 gallons, no big deal. The other piece is, how many times is it possible for a large system to lose power? If you lose power on a hot August day, the water in that 45-degree water is going to start warming up. Will it ever get to 100 degrees? I doubt it, but you want some little safety factor there. And if you've got a big system, you might bring the system down a little bit, like a university system that's huge. You might drop the 100-degree water down a little bit. But remember, what is the max temperature you ever expect in that system? And you also want to make sure you've got an expansion tank big enough to be the boss, to be the point of no pressure change. Also keep in mind, glycol expands at a different rate than water, and you need to take that into consideration when sizing tanks. So here's this screenshot of ESP Plus, and it really is a freebie. You can go online and get it. It really, really helps. You get this is the air removal system. But take a quick look. If you come in here and just check off what you're trying to do, like a commercial system, and you want to use a diaphragm bladder tank, great. It just walks you through it. What's your inlet temperature? What is your max temperature? What's your field pressure? Yeah, you've got to tell us what the field pressure to get you 4 pounds at the high point. What is the max working pressure in the tank? That's going to be limited by the ASME relief valve setting. How much to come into the system volume? How many gallons of water? We don't know. You're going to have to estimate that. If you want a quickie estimate, we have, if you click down deeper, you'll find a method to help you estimate the amount of water that's in your system. So you got to have the gallons, and then we got to have the fluid. If it's plain water, fine. If it's glycol, you can go a little bit deeper in that screen, and it'll give you the percent glycol. It'll help you come up with bottom line to hit size tank, and you've got yourself a nice little detail of what you're doing. It walks you through it. You're really going to love this, and I really would strongly advise you getting familiar with this and using it for selecting your tanks. Get a screenshot, keep it for your files, and you know what you did. So what can we do to fix a system where the expansion tank is too small? If it's a bladder or diaphragm tank, we should immediately check the pre-charge pressure. As you're going to see in a minute, we ship them from the factory at 12 pounds, and we need to make sure it's pre-charged to the makeup pressure to make sure we take full advantage of that bladder. So first thing is, did somebody pre-charge the tank? Unfortunately, a lot of times they don't get changed. They go in at 12 and then they get too small simply because we didn't put the proper air charge at the time of startup on the system. If we could decrease the fill pressure, now we got 12 pounds, let's say they give me 4 pounds at the high point. If we could lower that number, it will make the tank more effective. Change out the relief valve. We showed the boiler a little while ago where the ASME bladder tank, the B300, was too small. But that was because the boiler relief valve was 50 pounds. Maybe the boiler's rated for 75 pounds. Maybe the boiler's rated for 125 pounds. Maybe the manufacturer of that boiler will let us just change the relief valve and it's fine. And you ought to check that because a lot of times it's just that simple. A lot of times we get a low pressure ASME relief valve on a boiler and that same boiler is okay for 100 pounds. We just have to put a high relief valve on it. And now our tank works great. Move the tank to the high point. I don't think we're going to do that a lot, but tank at the high point has lower fill pressures, it sees lower pressures, and therefore it's going to be much more effective. Add another tank. We can always put another tank in parallel. The B300 there is not big enough. You can always put another tank in parallel. They work fine in parallel as long as you got one connection to the system at the point of no pressure change. There's no reason you can't do that. Change out the tank to a bigger tank. In our case, go from the B300 to the B400. More expensive, but it will certainly take care of it. Thank you. Have a great day.